designed one I have just done here. If you all have a paper and pen, please note it down. I am starting here some sample program. In yesterday's program, I have taken without the literal values. Here, in this sample assembly program, are you seeing the arrow mark? In this sample assembly program, I am taking the example of the source assembly language or the source assembly language program. In this, I think the screen has gone. There was a network problem, I feel. So once again, I am presenting the screen. So you can just see here the object code generation. Before the object code generation, this is the source program. Are you seeing the source program? Anybody? Anybody from the class, please answer. Yes, can you see the source program? Okay, fine. Maybe you're not able to answer, but I have. If there is any, the no, disturbance in the noise, please tell me. Pratik, at least you tell, no? Is there any problem? Okay. This is the source program, and this source program, it is generated from the this is the source program, and this source program is generated from the compiler. Assume that this is the source program of the assembly which I need to give as the input or the source for the assembler, or the source for the assembler. How is the program? The program is like this: start something, program has to begin, the starts program has to begin at the some constant location, that is the, even if you don't give, the program will start at the 0th location, even if you don't give. But here it is begin at 200, and something we have used the mnemonic code or the instruction, not code, or the instruction mnemonic word here it is, or the instruction move, are moving from register, moving into register the value called as 5. For this we say in assembler it is nothing but a literal, it is nothing but a literal. So in so for examples whatever I have taken in yesterday's example without the literal value I have taken, if you remember yesterday's program, the lab program. But today I have taken the program with the help of the some literal values. So far I was doing only using the symbols, I mean so far. So today I have come up with the some literal values. So here the first statement move R into register, that is the first category of the register is A, and it is 5 value is moved, and the next move from the memory the symbol A is moved into the register, from the memory the symbol A is moved into the register, and A add, next instruction is add, and the another category of the registers is C. So in this C register we are moving called as, sorry, we are adding called as the 1, that is another literal, it is called as literals. In assemblers it is called as literals. And here the speciality of to understand the literal pool, which is literal pool and literal table and symbol table, these are the databases or the data structures which are generated or which are constructed during the pass one, which are constructed during the pass one. And this is the resultant already which I have shown here. This is the resultant of pass one, this is the resultant of pass one. So everything typing there and showing you as a actual board, so it was taking time consuming. So here today I have just solved on the paper, and I have just screened you already solved one. And here the locations processing how it is I will be telling you. So here this is the program. So for the first program, so it is designed to scan for the first pass of the program. So the program as it begins from scanning, it starts from lexical analysis, that the start scanning of the start program. So it is started, so it is at the location called as 200. One thing you have to remember, for the even in yesterday's program for start also I have generated the intermediate code in yesterday's program, but those are unnecessary, or simply the memory size of the program it increases. So some assemblers do not generate for start, for assembler directives, for assembler directives some assemblers do not generate the intermediate code, it is not necessary. But even if you want to know what would be the intermediate code for the start is 01, it is an assembler directive. Ad it will be a pairing, how it will be, the tuple what I will be getting here, ad comma 01, ad comma 01, and the first operand is not there anyhow, the second operand is there, so that is C comma 200, that means constant is 200, constant is 200. In that way we can write. So today I have come up with some different one. I have not taken for assembler directives as the intermediate code, it not I have, it is told that in the book also we should not generate the intermediate code for the assembler directives. Even end is also an assembler directive, even end is also an assembler directive, but I'll be telling what about this. You may be thinking that here for end it is generated as assembler intermediate code, but it is not like that, I will be telling here. So here the location counter will be pointing or will be having the next line of the next instruction. So the next instruction what it is, that is move R. But how the location will be, initially the location counter it will be having here, as the location counter holds the holds the value of the next line to be generated. So that is the 200. Here the 200 value is the location counter for this line. Now to be processed, anyhow the tuple is nothing but for move r it is imperative statement, is is imperative statement, and 04 is the mnemonic code of this instruction, or the I must say as instruction code of MOVR is 4. Instruction code of MOVR is 4. And 1 is the first category, or 1 is the code of the first register, A register, first register. And here equal to 5. Equal 5 indicates that it is nothing but it is a literal, that it is a literal value, and its entry in the literal table, just observe here, its entry in the literal table entry. So these are the three different databases which are created during the pass one. But first entry, what we can see, as per the algorithm of the pass one, if it sees the literal table it has to be pushed on to the, sorry, if it sees the literal value it has to be pushed on to the literal table. So what is the first value which is pushed on to the literal table? That is nothing but 5, the value called as 5. But time being you should not look into the 203 and 204. We should not look into the addresses of 203 and 204. They are not the actual addresses of this line, of presently this line. So this is all, I mean this I have shown here full resultant itself. So don't see the address of 203 and 204. Time being, just see what is being scanned. First it is scanned as the literal, first literal, it has to go to the literal table, it has to make its entry as the index 01. First literal, that is first is 01, and that is the value of the literal is 5. But time being it keeps dash, still it will not come to know what is the address of the this literal. Next is move m. Move m, anyhow it's an imperative statement. So these all you know it, but still I am repeating for every class, so that each and every student should be known how is the intermediate code generation during the pass one, and how is the symbol table and literal table and literal pool table will get constructed during the pass one. So move m is also an imperative statement, and its code is 5, and AREG is the first category, and its code is 1. Code is 1. I must not tell first category or like that. It is a category of the register AX, so it is code is 1. BX is 2, CX is 3, DX is 4, like that. So here A register it is 101. And here we can see here in yesterday's example also I have been solved using some symbols only. So here also a symbol is there in the source program of the assembly source program. That is, it is nothing but a symbol, and it is a 01 index. Why 01 index? Where the moment the lexical analysis, the lexer sees A, it pushes A into the symbol table. It pushes A into the symbol table and says as the first entry, that is 01 entry. I mean, for its index is 01. Time being, again you should not see here what is 206 and what is 1. Time being they are blank only. Later it will get be associated, or later it will get be filled. At the end of the program will come to know. That is what A is treated to be as the forward reference. Till here at the line 2, it is an overhead for the assembler to decide, because here only A is used but not a declared, like in sub, like that we do no declaration part. It is not a declared, so it is a forward reference. So here somewhere it will be declared at the end of the program. So assembler will think, yeah, it will come somewhere. It is a overhead for it. So it will be haunting, it will be searching where A is declared, so that it keeps the address as blank, and its length also it will not come to know what is the length of symbol A, so that it will keep blank. Time being it will be blank at this line 2. Line 2 in the sense at the location called as 201. Now the next counter, how does it increases? Now here also yesterday I told you how does it increases the count, in the sense how, because based on the length of the instructions. You may be knowing the length of the instructions of all the arithmetics, except of all the arithmetics, or of all the instructions length is 1. It all depends on the type of the class, whether it's a imperative, whether it is a declarative, whether it is a advanced assembler directive. So it all depends what are the lengths of the instructions. So based on the length of the instructions, it get incremented, the location counter. Here it is 0 1, the location counter. Now here at the next location counter goes to the 0 2, which is for the next instruction. Based on the next instruction length, that is 1, 1 is been added to 201, so that it is nothing but the next address instruction is 202. Tomorrow I'll be telling some other example where the address location can be automatically increased. Here also I have one address location where automatically how it is getting increased, I'll be telling. But tomorrow also one more example I'll be telling how the address location can be incremented, or I mean by 2, like after, I mean if it is not in sequence. Okay, so here it also get incremented. Now here for add this instruction, that the location as 202, it is taking at the location 202 location counter, and its add is an imperative statement, and it's 1 code is 1, and it is cx register, so c register it is 3, and it here literal second literal. So here the second literal is found. So the moment it sees the literal, or the moment it is encountered as a literal, so it pushes on to the literal table. So that is a second entry into the literal table. So the value of the second entry into the literal table is 1, and its index is 0 2. Don't see the address, don't see the address. Now here again, what does it happens? Up to here the location counter is 0 2. Now the moment it encounters LTORG, again with the help of the length of the instruction, again with the help of the length of the instruction, assembler instruction, the location counter get incremented by 203. Here instruction is there, so the location counter get incremented by 203. One can ask now, ma'am, for every for all the instructions it is the length is 1 only or what? Of course it is the length is 1 only, but there are some instructions where the length is a little bit more, where the length is more for some instructions. That I'll display in by taking some of the help of the book, but in textbook of your Dhamdre it is not given. Okay, we can only read where how the lengths are being increased. Okay, based on the length, based on the length of the instructions it get increased. So here the length of the instruction is 1 for this instruction, so therefore here it is pointing at the location as 203. Now here the LTORG speciality is that LTORG is treated as the declarative statement. One thing you note down in your mind, that there are some assembler directives. What are the assembler directives? Start, end, origin, EQU, LTORG. These are the assembler directives. And whenever start and end, anyhow, there is no generation of intermediate code. And for origin, there is a generation of intermediate code with whatever the whatever the code is existing, or whatever the source program is there in this origin. So based on that, the intermediate code will be generated. But here is the case of LTORG, and it's of 05. Its code is of 05. And one more thing, the speciality of the LTORG, the moment LTORG means literal organization, the moment the literal the moment literal origin starts, so it starts saying, it start constructing the pool. The moment literal LTORG it encounters, it is treated that it is a declarative statement. It is a declarative statement, and now it will evaluate for the literal table. How does it evaluate? Now come here to the literal table. How does it evaluate for the literal table? The moment it sees the LTORG, the moment assembler encounters the LTORG, first thing you should think that LTORG is treated as a assembler directive, and it is treated as a declarative statement. Declarative statement. So here one statement I have made, it is treated as a declarative statement, and it is the assembler directive, and its code is 05. Its code is 05. That is how. But what is the story behind the LTORG? The moment LTORG it sees, it start checking the entries in the literal table. It starts checking the entries in the literal table. And what it does, it starts checking the entries. So far the entries in the literal table are 2. So far the entries in the literal table are 2. So it start generating the address for the entries in the literal table. So for, as I have told, forget about 203 earlier. Now the moment LTORG is seen, so it start generating the address for the literals. So that is nothing but the concept of LTORG, why the LTORG is used. Why the LTORG is used? Why? Because if there are literals in the program, to generate the addresses for the literals in the program, so, but how we generate the addresses for the symbols? We generate the addresses for the symbol based on the declaration. See here, A is there. Here A is there. A is there. So A is encountered here, and it is, and now once it is declared, so it start generating the address. It start generating the address. It shows that it is being executed. Now the literal values will get executed. So therefore the addresses are generated. So what is the address generated for 5 for 5 first literal? It is 203. Why 203? It will be in sequence only. It will be in sequence. 203 is for the first literal, and 204 is for the second literal in the literal table. In the literal table. So in this way, 203 and 204 are the two locations which are for the literals, which are for the so far literals. What are the so far literals? So far literals are 5 and 1. So far literals are 5 and 1, and yet they were not given addresses. Yet they were not given addresses. Once the LTORG is encountered, it start generating the address for the so far literals in the literal table. So it has been given that the addresses of 203 and 204 for both the literals whatever is present. And for this we say as it has finished so far literals. It has finished so far literals. So which is nothing but a first literal pool is being completed. That's what it is told as in the literal pool as #1. #1. Yes, Onkar, are you there? Onkar, Pranesh?
जी जी मैडम, सुन पा रहे हैं हम आपको।
Thank you. So that's what it is treated here as #1. Why #1 means this is a little pool again separate. As I said you that during the past one there are three different databases, and also intermediate code generation generates as per the pass one. So here as what it is seeing, it just pushes them into different categories. If it is seeing symbol, it push them into symbol, but they are being only used. So what they will be done, they will be further, assembler will be thinking that further there might have been declared. So once they are being declared, so it encounters them and start generating the addresses for them. But here LTORG is the case, so far case. Once LTORG is encountered, so whatever is present in the literal table, what was present, there were two entries in the literal table. One is 5 and the other one is 1. So what were those indexes? 1 and 2 were the two entries respectively. So but it was not assigned any addresses to them. Now it assigns the addresses to them, and this completes the first pool. This completes the first pool or the first entry, or this completes the first entry of the literal pool. That's what it will tell that 0, sorry, that's what it will tell here as #1. It will tell here as #1 means it has finished the first literal or first set of literal entries from the literal table. Now moving on to the next code, but I should finish here. For 203, now we have to define for 5, and we have to define for 1. So DL, as I said, whenever LTORG is there, you should declare LTORG as a DL. LTORG as a DL. DL in the sense declarative type, and its code is 5. And its code is 5. So here next is, anyhow here no operands, so I have taken here 0. If you want to present, if you want to give, you can give, otherwise you can give blank also to save memory. Yesterday in variant 1, day before yesterday's class I have told you. So in this way, variant 1 means memory size increases. In variant 2 it doesn't do any unnecessaries like this. So here unnecessary part I have done, that is I have not taken in LTORG there are no more literals like for move r move m. There are two operands, but in LTORG there are no operands. So I have treated here as zero operand, zero, its code as zero. Now next, moving on to the next pairing, that is nothing but, for what I am defining this, I am defining for the entry of the first literal from the literal table. This I am defining for the entry, because everything, even a dot, even a semicolon, even a comma, everything will recognize, everything will be scanned by a assembler, so nothing goes in vain. So everybody will be under surveillance. So this 5 also is under surveillance. See here how the 5 is treated. It is treated as literal table, so let me give it as an address. So everybody is having an addresses. So nothing goes in simply when, not even a dot simply it leaves. So for dot also it has got some pattern. So everything it has got a pattern, everything it moves according to the rule. So here 5 is treated. For 5 we have to define now what is the 5 intermediate code generates. Means it takes that as the DL part, means declarative part, because of the LTORG, because it is a literal and its code is 05 and there are no operands, so it is 0. And here for defining the first value 5, it is constant and its value is 5. Constant and its value is 5. Why I have denoted it by 3 decimals? Why? Because it helps me in understanding during the object code. It helps in understanding during the object code. So if you want here, you can also take here as 05. Next, why again this is continued? LTORG is also again continued for the another entry of the literal value, for the another entry of the literal value, that is 1. So again it is a DL in the sense declarative statement, and again it is a 5 in the sense it is code is 5. LTORG code is 5. Always I told you that LTORG should be treated as DL, should be treated as DL. And again its code is 5, and of course there is no operand 1, so it is 0 operand. And of course we have to define for the literal value, that is 1. So it is a C constant and its value is 1, 0, 0, 1. So this is now nothing but a literal values. These two are the literal intermediate codes. Now now you just analyze that now the literals are being executed, both the literals are being scanned. Still we have here somewhere a literal, that is in the next line. So how the address will get incremented here? So far here the address was, what was the last address for this line to be encountered is 204. 204. Now here we have 205 for the next for the next location counter it is 205. Why for the next location counter 205? Again it gets incremented by the length of the instruction, that is sub, it is 205. So at this line we have again 205. So for this is for sub, see this arrow mark, this arrow is for the location called as, is for the line or the statement called as sub statement. For that we have the location 205. Now again we have to start doing the intermediate code. The assembler starts scanning intermediate code, as it is an imperative, sub is an imperative statement and its code is 02, and its operand ag is 1, first operand, and the next operand again literal is there, it has to be pushed on to the literal table. Now here one more thing you should make note, that already 1 is there. One can ask me here a question, ma'am, already 1 is there, so again we need not to push that into the literal table. Of course we have to push this into the literal table. If if LTORG was not there, I would not have considered to push this again into the literal table. Now it will treat this, because these are the scanned one, finished one, executed one. Now what it will treat this, it will treat as a fresh entry into this literal table, as the second time, as the second time, or second entry into the second pool into the literal table. So 1 has to be pushed into the literal table, but of course its index is 3. But of course its index is 3. But of course this index 3, of course this index 3 is the second, of course this index 3 is a, sorry, of course this index 3 is a second entry in the literal table, and it is at the index called as 3, because this here index is 3. So therefore the second pool is started at the index called as 3. Getting here, all should understand here, this is very very important to understand the literal pool. In the first pool there were two literals. In the first pool there were two literals, and they got executed at the first index in the literal pool. And in the second pool, it is at the index called as 3. It is at the index called as 3, and it is denoted as has 3 because of the third entry. Because of the third entry, of course it is a second pool. Of course it is a second pool, but third third index. But third index. So here it is understood in that way. So here 1 is pushed on to the literal table. Time being, again you should forget here the address. Time being, again here you should forget the address. I just pushed the 1 into the, not me, the assembler has pushed just 1 into the literal table, has pushed 1 into the literal table. Okay, so whatever the code is generated here, intermediate code, that is, it is sub is imperative statement, and arg is a second code, and it is and it is, sorry, sub is a second code, and arg is a 1, and it is a literal, because equal to single quote is a literal, so it is a literal, and it is entry is 3. Its entry is 3. Of course it is treated as the another one, so therefore it is treated as the index as 3, but it's a second pool in the pool table. But it's a second pool in the pool table, but you should not denote as second, you should denote it the index number. You should denote here as the index number. So forget time being, the address of the one, freshly literal one. Next in instruction is what? A. Again A is encountered here. Already A is pushed into the symbol table. Now A will be recognized. Why? Because it is here declared as DS, data storage of size called as 1. So the length is declared as 1, and here automatically based on the length of the instruction, so here the location counter is increased to 206. So here this completes a entry, with the address and with the length. This completes a entry with the address and with the length. A is defined as 1 with the length as 1. Now encounters, now it feels, now its overhead finishes, means now its back patching finishes. Now it goes and back patching, where it was, here it was keeping blank only, these both were blank. And A, what was A earlier instruction at move m 201, now it will be referred this, now it will be oh, A is there, it will treat A is there in the symbol table. So now it will now it finishes its execution, saying as that, okay, everything now so far A was used, now A is also got has declared, so that's what A will be given as 206 as the address, and its length is 1 based on this declaration, and 206 is the address. Now for this DS, again you need to declare. But why you will declare, as it is a as it is a declaration constant, and it is also treated for declaration and for assembler directives. You cannot, if you want, you can write here the intermediate code. How the intermediate code will be? DS is a assembler directive, DS is a declarative part, dl comma, and its code is 02, and once again its operand 1, first operand is 0 and second operand is 1. 1 will be constant and its value is 1, and A is already, it has made its entry, so again this A will be repeated as yes comma 01. So that becomes an unnecessary code. Again, that becomes an unnecessary code, so I have not written it. So if you want, you can write here. So remember that always for start, end, and for some ds data storage, you need not to specify. And for some declarative statements, you need not to specify the intermediate code. Simply unnecessary the this depends on the versions of the processors, how it is. Okay, so but here I have not read it. Is again a repetitive statement, so that's what, because a was already defined here, so that's what I have not done here. Now next, end is also an assembler directive. End is as start is there, end is also an assembler directive, and its code is 2. But I have not defined for end also. Why? Because if you observe here, as I said, time being, this one was not defined, only this one literal was not completed its execution, so still it is not an end of the program. That's what here we should not treat as the end of the program. Now what it becomes soon after this, once it sees ads, once it checks, once the location counter comes to this part, comes to end part, at this location counter, it treats that the program is going to end, but still the one is not yet defined by the address. One is not yet defined by the address, so it start giving the address whatever is available, whatever is available. So the next available address is 207. 207, it will be allocated to the literal, to this literal one, to this literal one. And now this has to be generated, the intermediate code for the generation of the target code. So the intermediate code for this one, how it will do, dl as of this, as of these both literal ltrg, what we have defined for this two literals. So same like that only we should define for this one also, fresh one, that is fresh entry of the literal table is, which is of the second pool. So this is the entry of the second pool, so it is a declarative statement, and it is code is whenever literals are observed there, so you should give dl and 05. It's based on its mnemonic code. And no operands. Why no operands? Why no operands? Yes, why no operand? And one should not be confused that this n sorry, this end I have given. No madam, end code is 02, you have taken here 05. No, this code is for the literal last literal second pool. This is the second pool. Second pool is at the third index. Second pool is at the third index, so this code, intermediate code, is for that. So now completes the full program, or now completes the pass one after this. So how it is here, 0, 0 is for what? 0 is for 0 operand. There are no operand, only one operand is there, so that is constant c and 001. Constant c and 001, you should, as you should think that as the little LTORG only, like that only. So this completes the pass one. Pass one has generated what? Even the location processing also have done. It has also done the intermediate code, and it has also completed all the symbol table. Always remember, symbol table will help in will help as a side, will help as a mediators for generation of the intermediate, for generation of the pass 2. Now pass 2 for the, sorry, for generation of it also. Now pass 2 also takes the help of the symbols table, literal table, and literal pool table, and this would be more helpful for in generating the pass 2. How would be the pass 2? Now pass 2, what I have said, pass 2 is nothing but a machine code. It only picks the required code. It only picks the required code. Just note down here, I'll be writing here pass 2, what are the headings, it will be there. I should have taken the snaps after writing the heading here. Here I'll just type here pass 2. Pass 2, what it will take? Pass 2 it will take as, now pass 2 it will take as, with the help of the intermediate code, with the help of the intermediate code, it generates the object code. An object code is generated. To generate the object code or the machine code, even two in two words we say, machine code or object code or target code. it will take, how the heading will be, it will take location counter, and it will take the code, mnemonic code, and it will take the register, mnemonic code, register, and also it will take what? It will take the address. So these four headings you should remember. How these four headings you should remember. I'll make it with other. Okay, these four headings you should remember. What are the four headings? Location counter, location LC. Again, this you won't understand. Location counter. Check what is happening here. Location counter, and the another one what I said. The second one is the code, and the third one is register, and the fourth one is address. So these four are helpful for, it will pick only the location counter, code, register, and address. So you just see here in the same program. Can you write anybody? First one, what it will take? 200. 200 it will take, and after 200 what it will pick? 4, and after 4 what it will pick? 1, and after 1 what it will pick? It will pick after 1 the address of this literal. What is the literal? Just go to the literal table. So at 01 what is the address? 203. What is the address? 203, in this way. And next statement what it will pick? Their location as 201, and the code, mnemonic code of whose? 5 is for whom? MOEM. 5 is for MOEM. Again, you need not to go back for the source program. You should take from this intermediate code. For reference purpose, you can go back. But the assembler doesn't do like this. Assembler is not concerned with the source program. Assembler is only concerned with the intermediate code. This part, it is concerned with location counter and the intermediate code, and it is concerned with the symbol table, literal table, and pool table. Now here what is being observed here? 201, 05, then register 1, and yes is found. So go to the symbol table at index called as 01. What is their address? 206. So in this way it start mentioning. And next go to 202 and pick 01. Why pick 01? For add instruction. And 3 is for register. Again L is found, and go to L, literal table, and go at the index 2. Go at the index called as 2, and what is the address at 2? The address is 204. So start mention it, assembler starts mentioning in that way. And again go to 203 and check for 203. What is there for 203? 203, the address, sorry, not the address, 203 is found to be as what? Is found to be as 01. Why 01? Go to go to the literal. See here, go to the literal. So it is found to be as 010 and 005. Why 01005? See here, index is 01, 005 its value. That's what I have quoted here. 01 is its index and 005 is its value. And next you go to the next location, that is 204. At 204 what is there? Again you pick the same 01. Why 01? Why 01? Yes, 01, and again you go with the again you go with the value, that is 001 here, that is 001. For this it is treated as 001. So here also it is there as 001. Next, why 1 here? I should tell you. DL means, why DL? DL is nothing but a declarative statement, and here you, while coding, you should take DC. So that's what DC belongs to DL, DC and DS belongs to DL. So you should take here as they are constant, no, declaring constant. So it helps in object code generation. Whenever it sees this, it helps in object code generation. Okay, operand 1 is treated to be as the DC. That's what it will take here as 1, and here also it will take here as 1, and next address it will be as 03, and uh, here address it won't take, here 05, 005 and 001 it will take. I'll write here for this. So what is that? It is found at 203, and it is 01, and not only at 01, and its first operand was said to be as 0, then it was found at 005, and next 204, 01 and 0, and next constant was 001. So this is how LC is at 203. This I am defining for the location, sorry, this I am defining for object code for whom? Code for literal values, that is 5 and 1. That is for 5 and 1. Okay, in this way it generates the object code. With this I'll take the attendance. I think today I am a bit late to leave the class. 1, 2, 3,
Present.
4,
Present, ma'am.
5, 6,
Present.
7, 8, 9,
Present, ma'am.
10, 11, 12, 13,
Present,
Present, ma'am.
14,
11.
present,
15, 16,
Present, ma'am.
17,
16 present, ma'am.
19, 20, 21,
ma'am. Ma'am, थोड़ा slow है.
18 present.
Ma'am, 19 is present.
Ma'am, 20 present. 21 also.
22, 23, 24, 25, hello,
Present.
26,
41 present.
27,
26 present.
27 present.
29,
Yes, ma'am.
30,
Present.
31, 32,
Present.
33,
32 present.
34,
33 present.
35, 36, 37,
36 ma'am.
38,
Present,
39,
ma'am. 38 present, ma'am.
40,
Present, ma'am.
41, 42, 43,
41
44,
present, ma'am.
45,
Present, ma'am.
46, 47, 48,
Present.
49, 50, 51,
Present.
52, 53,
44
54,
present, ma'am.
54, 54,
55, 56, 57,
56,
57, Yogesh, 58,
yes,
59,
madam.
60, 61, 62, 63,
60 present, ma'am.
64,
65.
66, 67,
Present.
68,
Present.
69, 70. Okay, thank you.
70 present.
Why
68
you
present.
will be, why you will be telling very slow?
You are taking fast.
Ma'am, please repeat the roll numbers. Absent roll number.
Now okay, you post me. Now you join for the other class. Okay.